So recurrence relations can be really, really useful for predicting long-term effects. These are the kind of equations they use to predict climate change, population growths, um, disease outbreaks. Really, really interesting and quite important math. So it's really good to get a foundational understanding of it and use it to make your decisions. So in this question here, we're told a forest has 150 hectares of trees. Every year, 20% of the trees are cut down for industry. Every year, 10 hectares are planted. So this is assuming it only takes 1 year for a tree to match maturity. What are some of the long-term effects to this forest? So obviously, it takes a bit longer than a year, but for the point of this question, I'm just going to pretend it does. So what are some of the long-term effects? So will the forest just disappear if we take away 20% of it every year? 20%, 20% of that. Eventually, it'll just keep going down, 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 down. Okay. So the question is, will there ever be a point where all the trees get chopped down? Well, I don't know. We'll have to work it out. So we know that initially, there's 150 hectares, and we know that they're getting chopped down at a rate of 20%. So that's 1 minus 0.2, which equals 0.8. Okay, so there's 0.8 times as many trees left every year, but we also know that 10 new hectares get planted. Okay, so we can now build a recurrence relation out of this. So we know that un plus 1 equals un times 0.8 plus 10. Okay, so this is it here. Fab. So we can start to put some numbers in. So first off, we have so this is u1 equals 150 times 0.8 plus 10. So what is that? Oh, there you are. Spreadsheet is turned up. See that in a second. So we know that will be 100. If you just pop this in your calculator, this will be 130 trees. Okay, so what about u2? So u2 equals 130 times 0.8 plus 10. What does that give us? That gives us 114. So we can see just roughly that the trend 150 is going down. Okay, so now I'm thinking, oh god, is there going to be a point where all the trees are gone? So we could just keep working this out for ages and ages and ages, but I don't want to spend loads of time just typing in the same numbers. So what I'm going to do is pull up an Excel sheet, which I think I tried to find some other place to do, but I think this was the best place to demonstrate what we were trying to do. So here it is. Oh, a sec. Here we are. Right. So I've got my initial conditions in here. So u naught is 150. A is 0.8, which is junction of 20% every year, and then B is 10. Okay. So we need to think. Okay, how long before all the trees disappear? How long will it be? Or will they ever disappear? So how do we figure that out? Well, basically, we've got the formula here, and what I'm just going to do is copy this formula down. So okay, so we can see it's still decreasing, but it's starting to decrease at a slightly lower rate. Okay, so the decrease is slowing down. Okay, why is that? Let's keep going, and eventually, how long? How long is it going to be? Okay, yeah. So we can see here, it's actually getting to a point where it's no longer decreasing. It's just sticking at 50. And we're like, okay, well, why is that? Why has that happened? Well, basically, it's to do with it gets to a certain point where the level of trees is so low that if you take away 20% of the trees here, So what is 20%? So you take away 20% of 50. What is that? 10. Okay, and then you replace 10. So it just becomes this circular thing. It completely levels off. So the most, if this rate is kept, the most that the forest will ever be reduced by is to 50 hectares of trees. No matter how long you do it, if you keep up chopping trees down at this rate and planting them at the same rate, you will never drop below 50 acres, hectares even. So this is why it can be really useful, because then it can know whether things you're doing are sustainable or unsustainable. So what we're going to do now is go on to learn a bit about convergence and divergence, and then that will bring us nicely into learning about the limit of recurrence relations.